Welcome back, and we are now continuing to work with logarithms. And this video is going to introduce perhaps the most important properties of logarithms aside from the tattoo or the circle method, right? That converting between exponential form and logarithmic form. That is certainly number one of our things that we need to know about logarithms. But these three things are a close second. Okay, and I affectionately call these things log laws because it's fun to say. The alliteration, I love it. But the idea is that because logarithms are closely related to exponents and exponents have certain properties of them, logarithms inherit similar properties. Okay, and those three properties are here. Okay, product to sum, quotient to difference, and power law. Okay, I'm going to briefly outline these, but ultimately just kind of have to beat them into your head. This is one instance I might recommend flashcards. Usually I don't say that in math, but this might be one instance where you might need them. All right, product to sum. The reason it's called product to sum is because we literally take, if you zoom in, a product inside of a log, so that's multiplication, product means multiplication, becomes a sum of same base logarithms. So the way I remember this is log of a product is equal to the sum add of logarithms. Okay, so you just split it up. Multiplication becomes addition between logs. Next one, quotient to difference. Again, we have a quotient inside. Quotient means division, and that division becomes subtraction outside. Okay, one cautionary tale. Okay, students like to think that this is a property. Log base a of x over log base a of y is equal to log base a of x minus log base a of y, okay? This is not true, okay? This, if you remember from our previous video, this is more akin to the change of base formula. So if that's a little rusty, make sure to go back, review what that is, but these things are not equivalent, okay? Be careful with this one. Power law is the one that we love dearly, but it says if you have the exponent or if you have an exponential expression inside of a logarithm, that exponent can come out in front um, as a coefficient. Okay, and so we are going to spend our time practicing these in various ways, working from one side of the equation to the other, and yeah. If you want to see the proof, they are beautiful. It's all algebra, but I'm going to say it's in the book. Happy to go through it if you're interested, but I'm not going to do it here in the video. All right, so a couple examples, then we'll kind of summarize. So log of 2 to the x. Okay, we could, set it equal to y, but I'm just focusing on simplifying this. Okay, that's really what I mean when I say write an equivalent expression. Simplify. Okay, and what I notice here is inside this logarithm I have x, and so that I'm looking back at my rules, right? There is a power. Oh, I'm going to use the power law. So that power can just come outside as x times log of 2. Oh, and that's all the further I'm going to go. Yep, yep. Okay, so I'm done. Moving on. Natural log of 2xy. Okay, so how do I write an equivalent expression for this? What property or what law can I use? So do I have a power? No. Do I have a quotient? No, there's no division, but I do have a product. Product between three things, right? So let's, for the moment, just consider this as, let's say, natural log of 2, or natural log of 2 and then xy. So I could split this up versus natural log of 2 plus natural log of xy. Okay, so that product between them became a sum of same base logarithms. Okay, and then I can actually go a step further because between the x and the y, there's another product. So I could write this as, say, natural log of 2 plus, and then split this into natural log of x plus natural log of y. Oh, isn't that fun? Yep, yep. Okay, and that's all further I can go because now inside of a logarithm, I just have a single thing. Okay, so that's kind of how I know I'm done. I can't further represent the quantity inside in a more simplified manner. That's how I know I'm done. Okay, next, log base 3 of 12 over x. Okay, so I recognize that there's division. That's a quotient, right? So that becomes log of the numerator, log base 3 of 12, minus log base 3 of the denominator. And let's see, could I go further? Well, I maybe could. I'm gonna not for right now. So I'm going to consider this done. If you are a overachiever and you really, really want to, you could say, oh, this is log base 3 of 3 times 4. And really 4 is 2 squared. Okay, this is being super overachiever. And you could say this is log base 3 of 3 times plus log base 2 or log base 3 log base 3 of 2 squared minus log base 3 of x. And then finally, log base 3 of 3 is 1. That comes from your R log properties. Base matches, base of the log matches the input. That just simplifies to 1. And then this would be 2 log base 3 of 2, all minus log base 3 of x. Okay, so if you wanted to go that extra mile, great. The intention was just for us to use the quotient property. Okay, so in summary, we have these 3 logarithm laws, right? But we also have additional properties that I actually used in the last example with the quotient. Okay, we use this one, log base b of b is equal to 1. Okay, so now we have a ton of properties of logarithms in our arsenal that happen to correspond nicely to the properties of exponents. So this table here, if you don't happen to have all the exponent laws memorized or easily in your grasp, I'd say make sure that this table gets into your notes and formula sheets and all that jazz, because it is really important going forward. It's just having a firm understanding of what the exponent properties are and how the logarithm laws relate to those. Again, everything can always be boiled down to if you have b to the y is equal to x, that's the same as saying y, or I should say log base b of x is equal to y. Okay, so that might be an additional thing that you could add on there. But we have now fully explored all the properties of logarithms and how they relate to exponential functions.